Building a hardtop for your boat is an excellent winter project. Hi, I'm Joe with Motor City Boat Werks. This episode, I'm going to talk about how I built the hardtop for my Albin 27 pocket trawler. The Albin 27 came from the factory with just the pilot house. It didn't come with any type of covering that extended over the cockpit of the boat. The cockpit is the area of the boat between the pilot house and the aft cabin. There's an open seating area that's exposed to the elements. When I first bought the boat, I realized that this area really needed to have some sort of covering. Typically, these boats had some sort of fabric enclosure where a stainless steel frame, like for a bimini top, is on the inside, and then it has some type of umbrella material that goes around the outside. Now, this is a perfectly reasonable solution and a great way to create an all-weather room on your boat. But over time, well, these enclosures, they get a little tattered. They don't look very good. And frankly, they don't maximize the space that someone really needs if they're going to be living long-term aboard the boat. The solution is some sort of hardtop that extends from the pilot house all the way to the aft end of the boat. But this is not a very simple project. It's actually quite involved. There's a lot of things that go into the planning and design of an effective hardtop for a boat, especially one this size. Now, I'm not the first person who decided to put a hardtop on their Albin 27 family cruiser. Lots of other people have done it. However, one of the things that I never really liked about some of those designs was the hardtop didn't look like it belonged on the boat. In some cases, it was too flat or too square or too boxy. And it just didn't look like it came from the factory. It always looked like a design afterthought. So one of the things I wanted to do was to try and design a hardtop that looked integrated to the lines of the boat. I wanted it to look like something that maybe came from the factory as an option. It needed to marry the design lines of the boat, follow the curves and the straight lines of the boat where possible. But it also needed to be practical. My hardtop design had to meet a couple criteria. First, well, it had to be reasonably easy to construct. I'm just a do-it-yourself kind of guy. Second, it had to be reasonably cost-effective. It doesn't make much sense to put a several $1,000 hardtop on a several $1,000 boat. Third, it's got to be the right weight. You don't want to be putting a lot of heavy mass up high on a boat this size. It can really affect the handling and cause some problems down the road. So the weight's got to be within reason as the hardtop's being constructed. Also, I wanted to be able to walk on top of my hardtop, which means it's got to be fairly rigid and it's got to be attached to the boat in such a way that it's never going to be a problem. Now, I wanted the hardtop to have no frame on its underside. I didn't want anything that would reduce the standing headroom inside the cockpit. If you have a frame with ribs or any type of cross members on the inside of the hardtop, well then you're reducing your overall headroom. The last criteria, and probably the most important to me, was that it's gotta look good. It's gotta look like it belongs on the boat and that somebody didn't just slap a piece of plywood on there and call it a day. This meant that as a designer, I really had to pay attention to some of the details of what makes the pilot house on the boat even look good by itself. A lot of that has to do with the gentle curve of the pilot house top, both on the forward edge, the eyebrow that they call it, or on the sides. Well, those curves needed to be extended aft, all the way around the hardtop, 360 degrees. Also, I really needed to think about, well, what was the angle of the hardtop? Was it going to be level to the gunnel of the boat, the rub rail, or really should it be sloping aft to kind of give the boat a little more of an aerodynamic look? Now, the first thing you realize when you start doing a project like this is that The area that covers the cockpit of the boat is actually quite large. This is not just one 4x8 sheet of material. The area of the hardtop is actually something like 96 inches by another 92 inches. And what that means is that it's not as simple as using a single sheet of 4x8 material. You actually need two pieces of 4x8 material, and they've got to be joined together because they're going to be going laterally across the boat. I debated building my hardtop out of a variety of materials. I looked at marine plywood, I looked at various sorts of foam impregnated with epoxy, I looked at a variety of composite materials, and in the end, for a cost-effective, simple way to build a hardtop that still looked like it was design appropriate, I decided to use Coosaboard as my hardtop material. Because Coosaboard is rigid, especially once it has fiberglass laid over it, there's no need for an internal frame. For this project, marine plywood was just going to be too heavy. You don't want that kind of weight put up high on a boat this size. Now, in my other videos, I've talked about using Coosaboard, what it's like, what are the advantages of using this material, and why I consistently choose it for my boat building. If you're interested, check out the episode where I talk about repairing the rotted portholes on the boat, where I talk specifically about Coosaboard. Or I have another video where I talk about building a pilot house for a 16-foot sailboat. Even though I wanted the hardtop to have no frame, that didn't mean that I couldn't use a frame in its construction. On the Albin 27 family cruiser, the aft end of the pilot house has a piece of teak trim, and that teak trim matches the camber of the pilot house top perfectly. I was able to use that piece of teak trim to create a series of patterns for ribs that went inside a wooden frame. Now, the wooden frame was constructed of scrap pieces of 1x1 wood. I just kind of nail gunned them together. And then I took the panels of Coosaboard and I laid it across the frame and then screwed it down, especially the edges. And that's what created the camber of the top of the hardtop. To join the two 4x8 panels of Coosaboard, I used the staple and glue method. The staple and glue method is where you put epoxy on the edges of two pieces of Coosaboard. You put them together and then use a staple gun to staple along the joint. Just like a suture, that's what holds it together while everything cures up. One thing to remember is that the width of the hardtop, about amidships where the pilot house ends, is not the same as the width of the hardtop at the aft end of the boat. Of course, the boat is not square. It tapers at the bow and at the stern of the boat. So therefore, the hardtop also had to taper. The rib at the aft end of the hardtop frame was actually 2 to 3 inches narrower than the rib at the forward end of the hardtop. I dry fitted the wood frame on top of the boat. I held it in place by using some jack stands on the back of the boat. By using jack stands to raise and lower the end of the hardtop, I was able to get a nice angle which went from the pilot house all the way to the aft end of the boat. And I could experiment with different heights to see what looked good to my eye. It turns out that a gentle slope from the pilot house to the aft end of the boat of about 1 to 1.5 inches is just enough to make the hardtop not look too square or too boxy on the back of the boat. Dry fitting the hardtop while it was still on the frame in place on top of the boat allowed me to get an idea of where would the hardtop overhang. Would it cover all the cockpit seats and the back of the boat? I wanted to be sure that the hardtop would cover the entire cockpit so that if it rained, water wouldn't drip down while you were leaning against the seat. I often get asked the question, how do you get this curve on the edge of the hardtop to go all the way around the boat? Along the edges of the hardtop, while it was screwed to the frame, I went ahead and I cut some kerfs lengthwise along the leading edges. Kerfs are shallow cuts that you can make into a material so that you may ultimately bend it around a radius. By bending the edges of the hardtop and opening up the kerfs, I was able to create the gentle curve that matched the pilothouse edge. With the edges of the hardtop screwed down and the camber created, I then took epoxy paste and put it into the kerfs. At this stage, it didn't matter that everything looked kind of like a Frankenstein operation. That's not an issue. Remember, Coosaboard cleans up very, very nice. When you lay a final layer of fiberglass or you do any sort of filling in of any damaged spots or anything like that. Coosaboard is very forgiving and it's very easy to sculpt with woodworking tools. I was able to use a palm sander and a grinder to put nice beveled edges on all the corners and all of the leading edges. Wow, we have covered a lot of ground. That's a lot of information in a short period of time. And it seems like this is a good place to stop this episode. Join me next episode when I talk about how I designed and built the supports for the aft end of the hardtop. And I'll talk about finishing the hardtop and the ultimate results. This episode, we have a question from Miss Amala Diamini from Los Angeles, California. And Miss Diamini would like to know, hey, whatever became of the Oktoberfest Octopus Challenge? What did you decide to call the octopus? This is a great question. I want to thank you for your participation in the Oktoberfest Octopus Challenge. Thanks to your input, I've decided to name the octopus Spectre, just like the James Bond multi-legged Hydra. I think you'll agree, having a shop puss is a lot better than some whiny little cat. If you like these videos, please hit the subscribe button. These videos would not be possible without your support.